Hello everyone, in this video I'd like to discuss the string format in the PLC, especially for the Siemens TI Portal i700 or i7-1500 PLC, compare with the Allen Bradley Studio 5000. So I will briefly compare the string format difference between these two main PLC brands. And another motivation to discuss this string topic, that's because, as we know in my channel, I discussed the topic using Ethernet IP communicate between the Siemens PLC and Allen Bradley. So in my channel, I have COM26 and COM27, these two topics talking about using Siemens PLC can run as Ethernet IP scanner or adapter. Then this come up another topic. While the PLC communicate between each other using word, dword, or rail or float, they are quite easy. But if you have to exchange the string data between the different brands, how can we communicate? How can we transfer and receive the string correctly? In this video, you will see Siemens PLC and the Allen Bradley PLC for the string format. They are doing now the same. Okay. Firstly, let's go to the TI Portal, and I will show the i7-300 PLC and the 1500 PLC how they format the string. Then we will shift to the Studio 5000 Allen Bradley side. Then we will clearly see the difference between these two brands, how they can format the string. Okay, let's go to the TI Portal. Alright, from the Siemens side, firstly we have the Legacy 300 PLC. And we have the i7-1500 or 1200 PLC. 300 and 1500, they have slightly difference. So I will also show this topic. Let's start from this Legacy i7-300 controller. For example, this typical one, the very classic 315-2 PNDP controller. And while we set up this controller and after we set up this DB, we open this DB. Here, I declare the two strings. So after we declare the string, here in this DB data block, there's one column. It shows offside. This is the absolute address from this data block for 300 controller or 400 controller or i7-400 controller. And if we declare another one, string 3, you will see after you type a new variable here, it doesn't show the new offside till you compile. Then the system will show this offside data. Here, that means each string is using 256 bytes. This is bytes. The unit is byte. If you declare the next one, okay, compile, then the system will declare 256 bytes for each string. Then within this 256 bytes, how the Siemens controller arrange a string data, right? So from here, you're not able to see the detail inside. Alternative way, we can use the watch table. Now, let me open the PLC sim. And I will download this controller and I will run online. So we can monitor the online status from this DB data. Okay, now this controller is started. Okay, we can go online. Okay, so we can see we have a full strings from this 300 controller. And now I can write A, B, C, D. And second, I can write Siemens, okay, to this string. And then to monitor the details of this DB data, so we can use the watch table. And I can use the direct absolute data block address. So this is the DB1 here. So I will type in db1.dbd0, dbb0. B0 means this is the byte, and this is from the 0 byte. And then I can drag this. So basically, this is the first string. We'll also see the name. However, we'll see 0 and 1, it doesn't have the name here. But when we monitor this, we'll see it has some data here. And then the actual A, B, C, D 4 letters, they are all showing here. Okay, so what does it mean of this? If I change to the decimal, then we'll see 254. And also change to this decimal, we'll see it's named 4. So actually here, the first byte, that 254, that means the maximum length of this string. How many bytes it includes? It includes here, starting from here, it includes 254 bytes. And what the actual length? So DBB1, the second byte from this string. This is the actual length. It has 4 letters here. Then we can monitor the second string. The second string starts from the 256. So if I show DB1, the DBB 256, okay, decimal, still 254, okay, then we can drag it, okay, this is second string, still the first 2 bytes, it doesn't have the name, but the first bytes, it shows the maximum, and second bytes, it shows the actual length of this string. Siemens, it has 7 letters here. We'll see 7 letters. That's why this is the actual length here. Then, if I go offline, when we declare a string, if I like to declare a string with a shorter length, from the Siemens side, I can declare the string. For example, I can declare the string only with 10 lengths. Okay, I can declare the string. Let's call that short. It only includes 10 lengths. Then compile. Okay, then I can declare short 1, short 2. Let me declare 2 here. So we'll see this string takes 12 bytes. We'll see the difference between this address. It takes 12 bytes because bytes, the string bytes takes 10 plus 1 length, 1 actual, 2 bytes. So it totally 12 bytes. If I compile and download. Now if I type in a string here, think. Okay, then let's monitor. So this time, this start from the 1024. Okay, so I will name db1.dbb1024. Then let's drag it. And then let's monitor. Okay, we'll see. Okay, this time we will see the first one is not 254. 254, that means the maximum, because the string default, this is the maximum length. But if we declare the string like this way, that means it only has 10 letters include plus 2 bytes. So the total length of this string variable, this is the 12 bytes. So if we monitor here, think this word, it has 5 letters. That's why the actual length is a 5, but the maximum length is 10. So sometimes if we declare a lot of string in 1 dB, sometimes we better use the limited length because one string, it takes 256 bytes. If you declare 100 strings in 1 dB, basically it takes a lot of rooms for your controller. So you need to be very carefully while you are using the default string for Siemens controller. Okay, this is 300. Then let's shift to the 1500. You will see for 1500 to store the data from this DB block, data block, they are slightly different compared with the 300 controller. Okay, so let me go offline. Okay, let me close this monitor. I will close this simulation. Okay, let's shift to the 1500 PLC. Okay, 1500 PLC, now I'm using 1513 controller. So for all 1500 or 1200 PLC, so I only take 1513 this CPU as an example. Okay, then let's declare Okay, I declare the block like this way. Okay, default. It is the name based. Okay, then let me declare the string. Let's call string 1. I declare as a string. String 2, string 3. Okay, I declare 3 strings. Then we will see slightly different here. So this is the 1500 string, right? So I will float it. And then meantime, I will also open this DB string here from 300. Okay, so 300 here, 1500 here. So here you will see a difference. 300, this is the absolute address based controller. Here it has offsite absolute address. But for the 1500 PLC, it is name based, variable name based. So it doesn't have the offsite data by default. By default, if we monitor the string, okay, we will monitor the string by the name. For example, if I open the watch list, okay, if I drag this string here, if I start the monitor, it is only monitoring this whole string because this is the name based. You are not able to see how this string store the data, which way it store the data, what the format inside. That's why a lot of people confuse how Siemens 1500 PLC, 1200 PLC store this string. How can we convert some other data into this string? Then, how to know this detail inside? So default, this is the name based. For Siemens controller, for 1500 and 1200, default is like this. However, we can change this way. So now I close this here. So now I close this here. Again, now it only has start data, right? It doesn't have the offsite. But now if I go to the properties of this DB, I go to the attributes. Here, default, this DB belongs to the optimized block size. If I take off this, turn off, then immediately you will see the offsite column show up. We haven't compiled yet. After we compile, you will see the offsite address will be showing here. So once we take off this, then the method to store data from 1500 and 1200, they will be the same as the traditional legend controller, 300, 400. Once we take off that optimize, once we take off this, then those CPU storage method, they will be the same. Okay, so after we take off that option, then let's compile. Then we will see the method. It will be the same as 300 side. Okay, again, so here I will declare a string short, short 1. Then I will declare the string 10. Okay, we will declare the string 10, 3 strings here. Okay, now I will use the simulation and we will see how the actual string stored into this data block. Okay, let's turn on the simulation. Okay, let's start up this simulation controller. All right, now let me go online. Okay, same thing. So from this string here, I will type in the Siemens word. And second one, I will say hello. Okay, for the short one, I will still use think as an example. Then let's monitor. Let's go to the watch table. Open watch table. So once we take off that optimization, we will see this string name will be translated to an address. It will show address here. So we will delete this, and I will use the same way. So first string, that is a db1 dot dbb0. Okay, I will drag a certain length. Okay. into the decimal. Then we will also monitor this short one. This short one started from the 768. Okay, so this is a db1.dbb0. dbb 768. Okay, drag it to a certain length, decimal. Then let's monitor. So we will see default from 1500 side, default the maximum is 254. 254 is the maximum letters stored into this string variable, and the actual length from this second byte. Okay, if you declare a string with a shorter length, so this maximum means 10. 10 means the maximum length of this word, of these letters. The maximum length of these letters, this is 10. Totally, it takes 12. We will see from 780 to 792, it actually takes 12. It also needs 2 bytes store the maximum and the actual. Actual length is a 5 letters. Sync. 5 letters. Okay, so this is Siemens way. So basically, it has 2 headers. One is the maximum, one is the actual. Okay, so we'll leave this talkie here. Then let's shift to the Allen Bradley side. All right, this is the Allen Bradley Studio 5000. And currently I'm using the compact logic controller as an example. For the compact logics or control logics controller, they are using the same way. So we go to the controller tags. So now if I declare a string 1, string 2, okay, and I will change the string. And I will declare these 2 variables as a string. Okay, then once we declare this string from the Allen Bradley side, you will see there's one expansion button here. Then we are able to see the details inside. So if we declare this string, if we go to the monitor tags, so if here I declare this variable, give a name, for example, give a word here, hello, and here declare the weekend, this word. Okay, then once we expand this string, then we'll see it shows the actual length and then the following data. Each data takes 1 byte. Okay, this is the int, short integer, a byte length. Okay, hello is here, and this is the actual length. And the second string, the actual length, weekend, it has 7 letters, so the length is 7. Okay, and this is the actual word. And the data area that stores the actual letters. Okay, so here we will see the data, it has 82 lengths. So firstly, from the Allen Bradley side, the string only takes 82 at the maximum length. From the Siemens side, it takes 254, the maximum length. So the maximum length from these 2 brands, they are now the same. Here, Allen Bradley side is 82, Siemens side is 254. And another difference here, the length here, it takes double integer. So take care, from the Allen Bradley side, the length here is using the double integer. The actual length, it actually takes 4 bytes. Is using 4 bytes represent the length, and 82 bytes store the actual letter data. Okay, and it doesn't have the maximum length because the maximum length has been declared here, it pre-stored. So we will see the difference if I side by side compare these 2 things. So from the Siemens side, the top 2 bytes is stored the maximum, and the actual length is using byte to store these 2 data here. But the Allen Bradley side, firstly, it doesn't have the maximum because the maximum is actually from this 82 here. Okay, and the actual length is using the double integer, 32 bits. 32 bits, basically 4 bytes, store this actual length. Okay, so with this comparison, we will see if you have to transfer the data between these two different branch controller, so you have to manually realign the string data from these two sides. For example, definitely you have to send the actual length. So you need to put this actual length 7 from the Siemens side, then transfer to this Allen Bradley side length. Okay, and also you need to take care from Siemens side, this is the bytes. Here, this is the double integer. And the actual string, they are exactly the same way. Okay, they are using the ladder, the ASIC basically, using the ASIC. From Siemens side, this name the characters. So if I change this string with the same weekend here, so I transfer this weekend, okay, then we'll see if I convert this to just transfer this monitor style to hex. Okay, this weekend hex. Then same thing from this side, I will change to the hex. Change to hex. So we'll see the bytes by bytes, they actually the same thing. 57, 57, the last word, the last letter is 44. 44 here. So the string, the letter, they are exactly the same way. Whatever monitored by the hex or by the ASIC or character. Okay, they are the same thing. Okay, but the header, they are not the same. So if we have to transfer the data, you need to take care of the actual length. Once you figure out the actual length, then the rest of things you can transfer the letters only between the different controllers. From other brands, for example, Omron or Backoff, they will also do the string slightly different. So you better use the absolute address to figure out how they format the string variable. Okay, so this is the topic for today. Thank you for watching.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.